it's, I think, about time to get started. I want to encourage all of you to keep up with the homework and keep it in. It'll pay off for you. We have that post-test here in a couple weeks, and we'll talk more about it as we get closer to that time. We have a few more topics we want to cover, but keep up with the homework. Remember, there's two things each week. There's a classwork, which we do most, if not all of it, together. And Mrs. Jacket checks that as you turn it in. Be sure to show your work on that. And then there's a homework paper that goes along with the classwork that you work on your own that parallels that. So remember, there's two things each week. Well, I'm going to share my smart board. Okay, this is week 4. We're halfway through. So today the objective is we're going to do a little review of the first half of the math topics that we've had. So we're going to do 2 parts of it today. First, I have some problems I've just written down that I thought would be helpful, and then we'll go over the classwork that's listed for you. So let's get right into the problems. The first problem says, if you have this series 0, 3, 6, 9, and so on and so forth, what is the value of the 10th term? Now you could, if you wanted to, you could figure out and say, well, he's giving me 4, and I'll figure out which type it is. And that works for a while, but what if it was, what is a 100th term? After a while, you're wanting to see how to use the equations or technical reading. So let's look at that, okay? Let's look at this one right here and see if we can look up formulas that we have in our notes, or look them up on the internet or Google or whatever. Okay. There's the problem that we just have written down, and I want the 10th term. In the problem so far, they've given us A1, A2, A3, A4, and we're looking for the 10th term. I've told you that so far there's all types of it, but the 2 main types are arithmetic and geometric. And I'll figure out first off which type it is. If it's arithmetic, there's a common difference. In other words, from here to here is 3. From here to here is 3. From here to here, oh, it's arithmetic. So then, I would use these equations in my technical reading to try to figure out the problem. The first one says if you want to find a term, and this one says sum. It seems like that's what they want us to do with series and sequences as you go on in the study of math. What is a particular term in a series, or what is the sum? The sum of the first 2, the first 100, the first 1,000. For a variety of reasons. Right now, I'm just saying, can we do it? Okay, we've decided that it's arithmetic. So I don't need these over here. And I want a particular term, a sub n. A sub n. So if I want that, I'm going to follow through on this. And it says to take a sub 1. Well, I know the first term is 0. That's a sub 1, 0. Then it says add n minus 1. Well, they told us what n is. It's 10. So I'm going to add to that 10 minus 1. And then it says take the common difference. The common difference. Well, the common difference between all of them up here is 3. So as I read that equation, again, it's technical reading equations. You see more and more of it in our society, and all kinds of things, everything from cell phones to putting together furniture, from Target and Walmart to buying electronics. There's all types of equations they want you to read. Okay, on this one right here, I'm going to do what it says to do. 0 is easy, it just drops. 10 minus 1 is 9. 9 times 3 is 27. So the answer to that problem, the 10th term, is 27. And if I wanted to, I could say 1, 2, 3, 4, 5, 12, 6, 15, and figure it out that way too until it gets out of hand like the 100th term. The answer to that first problem using this equation was 27. Is there a question about that one? Hey, Brad?
Yeah.
Brad, say something.
Yep.
Okay, I've had a problem last week, Brad. I just want to feed you in this second. If I say Marco, well, mute yourself and say Polo. I've had a little trouble, not them hearing me, but me hearing them. So occasionally, when I ask questions and no one says anything, I might say Marco.
Sure. Yeah, I will respond.
Thanks, Brad.
Uh-huh.
Okay. Let's go back and take another look. That was the first one that we worked. Problem number 2 on review of what we've had so far. On this one right here, it says we have a series again, 8, 12, 18, 27, and it asks for the ratio and what is a sub 1. Oh, well, if it's a ratio, it's geometric. That tells me that automatically. All they ask for is the ratio. And then they ask for what is the first term? Well, the first term they've given me. It is 8. So half the answer they've already given me. I just had to be able to read and understand what they wanted. Now, it would have been a much harder problem if they would have said, what is A of 52? What's the 52nd term? I have no idea what it is. I'd have to go to those formulas and read. But here, yeah, pretty easy. The first term, which was given. It asks for the ratio. Well, I know the ratio is what you multiply to get from one term to the next. In other words, I had to multiply 8 times something to get 12. And that should have been the same number here and the same number here. Well, if I do that, I'm going to make an algebraic problem out of it. I'm going to say 8 times some number, which we're going to call the ratio here, equals the next term, 12. Get rid of the 8, I divide both sides by 8, divide by 8, divide by 8, and the ratio is 12 eighths, or taking out 4 out of each of them, 3 halves. So I multiply each of them by 3 halves. Now, I was always paranoid in college, so I always tested it. In other words, 3 halves, the next term is 12. So I said times 12. 2 into 12 is 6. 6 times 3 is 18. Well, sure enough, the next term is 18. So the answer to the ratio in this problem is 3 halves. And that's the answers there. Questions about that example? Okay, let's look at the next one. Number 3, what is the sum of the first 12 terms? Well, if I did it by hand, I've only got 4, so I'd have to find all 12 of the terms and start adding. In other words, there's 15. 15 and 15 is 30. 30 and 20 is 50, and I'd have to do that 12 times. However, if it's an arithmetic or geometric, we can use those equations. Let's see if we can do that again. Use those equations. And this is not too bad because it said the 12th term, not the 150th term. So I go to my book or go to Google or somewhere and look up the equations, and here they are. And there's my question that I have here. What's the sum of the first 12 terms of this series? Well, first off, I'm hoping that it's either arithmetic or geometric. one of the two. So I start looking at it. If it's arithmetic, I think, what do I add? I add 5. What is it? I add 5. What is it? Well, it turned out again, it is arithmetic. So I'm going to use these equations right here. So the first thing you do, a lot of times when you do technical reading, you have to use it 2 or 3 times and depend which way to go. In other words, if I bought a piece of furniture, tables and chairs from Target, start to put together and say, identify these parts and go to pick up the bolts that are A. Well, I have to figure out what's A. So in technical reading, a lot of it is figuring out which part do I go to. And here we had 2 choices and figured out that it was arithmetic. In other words, there's a common difference, and that difference is 5. Okay, it wanted the sum. So I'm going to use this set of equations right here. So again, I don't need these. And we do that all the time, like a table and chairs. I picked up bolts A. I don't need B, C, D, E, and F. It seems like there's 100 of those things when you look at them. But you got to decide first which ones you're working with. So right now, I know I'm working with this set of equations. Okay, the first 12 terms. So N is 12. I know that. I know the common difference is 5 every time. So I look at the sum right here, the sum, and it says take N. So the sum equals N. Well, N is 12 divided by 2. Then it says take the first term. Do I know the first term of the series? Well, of course I do. It says 5. I know the first 4. And add to it. Oh, I don't know this one. It's the same thing putting that table and the chair together from Target. It says after you get bolt A in slot C, then get the bolt C, and you have to figure out what bolt C is. So now I have to take this and go back to this part of the equation. Okay? So one thing leads to another when you're doing this technical reading or scientific reading. So now then I'm going to do the top equation and find out what is the 12th term. So A sub 1 is still 5. So I'm going to do 5 plus N is 12 minus 1 times the common difference. Well, the common difference is still 5. So the 12th term is 5 plus $12 spin 1 is 11 times 5. And that's 5 plus 55, which equals 60. So the 12th term is 60. So now I can come back down here and put in 60. Do the arithmetic. Half of 12 is 6. $5 plus 6 is 65. Six times 65. 6 times 5 is 30, carry my 3. 6 times 6 is 36, and 3 is 39. So the sum of the first 12 terms, I think, is 390. And again, I could have done that by hand. 12 is not too many, but if you want the sum of the first 1,000 terms, you certainly wouldn't do it that way. Questions there? Questions there? So it's a little practice in what we've done so far in technical reading, reading equations, and being able to apply them. It's just hugely embedded in our society. There's no way you get around it. There's none of you that would go out and buy the new i11 phone and be able to use every feature on it the first day. You've got to take that manual and read it and see what the different things are. And it's just something that is not going to go away. We need practice at it. And there was one way we could with series and sequences. Okay, let's go back. Okay, we did that one. Next example. Symbols in math. Do you remember that? Do you remember what Greek S means? Sigma, it means sum. By the way, in math, a lot of times you see Greek letters and sometimes occasionally Latin, but boy, you see a lot of Greek letters in math. The reason is when a lot of this was being developed 300 and 400 years ago, the foreign language that was taught in many European and other civilizations was Greek, and that's why you see a lot of Greek letters. However, I do want to point out to you the numbers we use, like 2 and 4, they're Arabic. That's from the East. So there's a lot of different cultures that affect how we do in mathematics. There's a Greek letter sigma. See if you remember how to do that. On your own, do that problem. I'm going to give you 30 seconds. See if you can do this on your own without me telling you, and then after 30 seconds, I'm going to work it out. Can you tell me what the answer to that problem is?
Good morning, sir.
Okay, let's see if we agree or disagree. Maybe you have an answer now. Again, this happens so often in technical reading. It will say, take a, it will say take an Allen wrench and take both C. Well, this is like an Allen wrench. If you don't know what it is, you have to look it up. And usually there'll be something that will tell you what it looks like. And it means sum. So if I was looking at this, it says take 4 times the number minus 2 and do it from 1 to 4. So if I wanted to write it out in detail, I have 1, 2, 3, 4 things. And in between them, that Allen wrench, that sigma means to add up. Well, if I take 1, that's 4 minus 2 or 2. If I take 2 right here, that's 8. $8 minus 2 is 6. If I take 3, 3 times 4 is 12. $12 minus 2 is 10. And if I take 4, 4 times 4 is 16. Minus $2 is 14. And then I'd add those all together. That's 8, 18, 18, and 14 are 32. Now, maybe or maybe not before you had this class, maybe you've never seen that before, but it's built into the calculator just like the sine and cosine functions are, which we'll talk about next week, or add, subtract, multiply, divide. It's used enough or it's in the calculator. And the calculator would do that as well, but that's a simple one. If this was from 1 to 400, I would certainly learn how to do it on a spreadsheet or the calculator or something with technology. That's what technology does for us. It's able to compute. Is there a question about that? Question, anyone? Well, let's look at another example. It's been a while. It says you flip a coin 3 times. What's the probability of B? And B is you get at least 1 tail. A is you get exactly 2 tails. Well, I'm looking at this one right here. Probability seems simple enough on it. Probability equals the total, or we call that sample space in statistics, over what's in your favor. Favorable outcomes. If most of you go on to take any kind of topic in college, many of you will be asked to take 2 math courses. One of them is college algebra, and the other one is statistics. Now that's just about for any major. Now, if you get into the sciences or electronics or industrial type things, you'd be asked probably to take more than that. But statistics is certainly one of the courses that's really embedded in our society as well. And probability is one of them. If you take that elementary statistics, nearly always you have three coins flipped or something with coins. And the reason is the sample space is easy to look at. Let's look at that sample space first before we do this one. Flip a coin 3 times. I've drawn a graph of that, okay? In other words, if I flip a coin 3 times, it could come out right here. 3 heads, 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 heads. That could happen, it's possible. But if you look, there's 8 different outcomes. 1, 2, 3, 4, 5, 6, 7, 8. And the reason in statistics they usually start with flipping a coin, I can see 8 outcomes. Now in real life outcomes, there's so many more outcomes. In other words, if you're in the medical profession and are testing new drugs for a variety of reasons, that's really in our news right now. There may be thousands of outcomes, but before you can understand thousands, you have to be able to understand something that we can see. In this example, just 8 outcomes. Well, let's see if we can answer that question. Number 5, it says you flip a coin 3 times. What's the probability of B? And B is you get at least 1 tail. Okay, not here. Yep, I get at least 1 here. I get 1 here, at least 1 here. Yes, 1 here. So B, what was in favor, is 7. The sample space is 8, so the answer is 7/8. And in statistics, you'll see it really 2 ways. 7/8 is very common, but also you'd see in the probability, and that's 87.5%. So it's very likely to happen. If you flip a coin 3 times, I would think nearly always you would come up with at least 1 tail. Question about that one? Well, the next problem right after that says this. What's the probability of A and B? And there's 2 quantifiers. One is OR, which means union. This one that we're looking at is intersection. What's the probability those intersect? That you get at least 1 tail and you get exactly 2 heads. Well, if I'm going to do A as a green dot at exactly 2 heads, right here's one of them. There's exactly 2. Right here's one of them. There's exactly 2. Not here. One right here. Not here. Not any of the rest of them. So on the get at least exactly 2 heads, there's 3 out of 8. However, what we want here in this problem is their intersection. Well, the reason I drew this graph out, you can see what they have in common. Intersection means and. So there's 1, 2, 3. It turns out the answer to our problem is 3/8. And you can see it doesn't take much on probability to get fairly involved, but it's something that we use in our society all the time. Right now, they're looking for a cure for COVID-19, and they're looking at probabilities. And when they test those drugs, when they have those test subjects, actual people, in some cases it's lab animals, that they'll look at probabilities. In other words, what was the probability this drug worked? Well, this time it was only 3/8. Well, we're going on to the next drug. That's not good enough. Oh, 7/8. Well, maybe we have something with 7/8 that it worked almost 90% of the time and then go on. So probability, there's just a lot of different things. Your car insurance is higher than my car insurance. And the reason is per capita, it's teenagers have more costs for cars and insurance than what elderly do. Yeah, I'm elderly. I said it, Daniel, so it's okay. The alternatives are good. So there's all kinds of things we could use probability with. And that was one of them, flipping a coin. You remember what the other probability was? You might remember the other one that we've looked at? Sample space is a little more. It was cards, and we'll do one of those here in just a second. Factorials, can you do that one? It's on your calculator. Remember what factorial means? Sigma means to add. Factorial means to multiply. So this problem is asking you to take 100 times 99 times 98 times 97 all the way to 1 and divide that by 99 times 98, that's 99 factorial. See if you can come up with an answer. Take about 15 seconds on that. The answer is 100. These numbers are huge, okay? At about 72 or 73 factorial, somewhere in there is a Google. Now, if you ever wondered Google online, you said, gee, I used Google this morning to check my mail. I looked at the Google mail. The reason they named it Google, they were nerds just like me. Google is 10 to the 100th power. And the goal was, when they invented this, to have at least that many bits of data. That's a huge number, 10 to the 100. They far exceeded that, by the way, far exceeded it. And if you tried to do this on the calculator, my guess it wouldn't work. But I know 100 factorial is 100 times 99 factorial over 99 factorial. It turns out to be 100. So the technology has its limitations. In your calculator, it goes up to about a Google, 10 to the 100th power, and then it can't do add, subtract, multiply, and divide anymore. Number 8, do you remember how to do permutations and combinations? This is 8 factorial divided by 8 minus 3 is 5 factorial. So 8 factorial is 8 times 7 times 6 times 5 factorial over 5 factorial. Now, if you wanted to, I showed you also that you can do this on your calculator as well. It's under math, and you write it just like I circled there. In any case, the answer is 336. Whether you use this function on your calculator or whether you do it by hand. And on a permutation, we use it in probability all the time. Right here, I'm just asking you to use it, but order makes a difference. Order makes a difference. What I mean by that, 12 does not equal 21. If order did not make a difference, those two are equal because the order doesn't make a difference, the 1 and 2. In numbers, it's always the permutation makes a difference. If you take me for elementary statistics, I'll explain that. Right now, I'm just wanting you introduced to a permutation 336. Is there a question there? Is there a question there? Well, if you do a permutation, you do a combination. If I would do this, it's 6 factorial, starts out the same way, over 6 minus 2, which is 4 factorial. But you also, in a combination, pick up whatever this is, factorial. So this would be 6 times 5 times 4 factorial over 4 factorial times 2 factorial. And 2 factorial is 2. These would cancel. 30 over 2 is 15. And again, you could put it in your calculator. It's under probability. We talked about that. If you want to use that key, it works out fine as well. And on combination, order does not make a difference. And if we were in an elementary statistics class, we work problems with them. Right now, I'm saying, can you do the arithmetic to get the correct answer with those? Okay, here's the other probability that we did. Draw 2 cards from a deck of 52 with replacement. What's the probability they're both black? Now, if I draw 2 cards from a deck of 52, that outcome, that sample space, is over 2,000. It's 52 times 52. Why? Because there's 52 cards. Remember, there's 1, 2, 3, 4 suits, and there's 13 in each of them. And 13 times 4 is 52 cards. And again, the reason the cards are always used in elementary statistics, they'll get out a deck of cards and say, what is the probability? And go through it and actually do it, and it works. It really, really works. Well, let's see if we can answer this question. They both are black, so there's 26 black cards. I draw the 2 of clubs and put it back in. On the second draw, there's still 26 black, and I draw the 2 of spades, and there's my answer. And usually they'll want you to reduce it, so it's 1/2 times 1/2. The answer is 1/4 or 25%. So it could happen. It happens 25% of the time. Questions there? Number 11, solve using the quadratic formula. Hope you have it down now. It's the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. It's quadratic because if I factored it, there'd be 4 terms, but the square term gives it away. Well, I have my a, b, and c, so I'm going to go ahead and solve the equation. Opposite of b is -2. 2 answers, that's the plus and minus. B squared, well, 2 times 2 is 4, minus 4 times a, which is 1, times 8 is 8. However, it's a -8, so that goes to plus. All over 2a, which is 2. Doing the arithmetic, I have -2 plus or minus 8 times 1, or excuse me, 4 times 1 is 4, times 8 is 32, plus 4 is 36. All over 2. I know what the square root of 36 is. It's 6, so I have -2 plus 6. Or I have a -2 minus 6 over 2. If you use the plus part, 4 over 2 is 2. If you do the minus part, -8 over 2 is a -4. So there are 2 solutions to that problem, and I could have factored as well, but this formula, there's no way you're going to take the ACT, the SAT this fall or in the spring and that not be on it one way or another. And they expect you to know it. And again, it falls under the category of doing technical reading. And the last example before we go to the classwork is this one. I to the 18th, I would say that's I to the 16th times I squared. I know any exponent that's a multiple of 4, if the square root of -1 is just 1, I squared is -1, so the answer to this one is -1. You can also do that just like that on your calculator, and it will show you the same answer. And the last example before we look at the class worksheet is this. You would FOIL. 2 times 2 is 4. 2 times 3 is a -6i. 2 times 3 is 6i. And 3 times 3 is a -9i squared. 6 minus 6 is 0. 4. I squared is a -1, so it's really 4 plus 9 or 13. So those imaginary numbers are different sometimes, and again, it's something that I know that you're going to see on the ACT or SAT, working with imaginary numbers. And you get into it when you solve quadratics, so this seemed like a good place to work. Let's look at the classwork area for just a little bit. Unmute yourself, because I'm going to go through these quickly. Unmute yourself. Does anybody want me to work one? I'll wait 10 seconds. If no one says anything, I'll go on. Someone says something, I'll work it. Anybody want me to work number one?
This
The
is
answer
just
is
a
arithmetic.
This is just a test. Can you
Anybody want
hear
to
us,
work
Mr.
number
Babcock?
two?
Can you hear us?
We did one like it. The answer is
Polo.
36. Now I'm giving you the answers.
Polo.
So I want you to know them out. Make sure you say now, oh, I've got the answer. Well, you better make sure. And I've worked examples of all these. Hey, Brad, say something.
Polo.
Oh, I can't hear. Hey, Beth. Okay, I am. I'm changing it right now. Thank you, Beth.
Can you hear us now?
Guy got really rich asking that question on TV for a while.
Yeah.
Just dated yourself, Brad.
Yeah. Then he did his
Daniel, say something now.
Can you hear me, Mr. Babcock? Can you hear me?
Say something now, Daniel.
How about now? Is it working?
Try speaking in dad
Try
jokes.
again, Daniel.
How about now? No.
Try it again, Daniel.
Can you hear me?
Got it back. Thanks, Beth.
Okay.
Okay, let's go back to the problems. Did anyone want number two? Okay, number three. Does anybody want number three? Answer's D. Anybody want number four? If you work it out, I hope you get C. Now, when you hand this in, Miss Jacket needs to see your work. Hope you understand that. The only reason I'm not working them all now is short of time. Anybody want number five? Ooh, look at that, A of 52. Anybody want number five? It is C. Marco.
Polo.
Thank you. Just checking. Number six. Does anybody want to see six? When you read those equations, it should be A. If you don't get that, you ought to ask yourself what's going on. Oh man, look at number seven. Your favorite. It gets into fractions. Oh my goodness. Does anybody want to see number seven? Answer's A. Number 8, we did one like that. Does anybody want to see 8 worked out?
I wouldn't mind seeing that one more time.
Okay, it's from 1 to 5. So we have 5 terms. 1, 2, 3, 4, 5. I'm going to put a 1 in here. 1 times 3 is 3, minus 3 is 0. I'm going to put a 2 in. 2 times 3 is 6. 6 minus 3 is 3. I'm going to put a 3 in. 3 times 3 is 9. 9 minus 3 is 6. I'm going to put a 4 in. 4 times 3 is 12. 12 minus 3 is 9. Guess what the fifth term is going to be? Yes.
12.
12. And
Okay.
in math means to add. That's 3. 6 is 9. 9 and 9 is 18. And the answer is 30.
Thank you.
Welcome, Daniel. A lot of calculus is based on this premise. You do the sum of things and do it to infinity and beyond. But anyway, all I want to see now is the sigma. What about 9? Flipping the coin 3 times. I had that sample space drawn for you, and I would look at it. Or does anybody need to see number 9? The answer is 50%. Okay, number 10 is the same. It's not any different than that. It's just I changed the event. It says exactly. That answer is C. And the last page, it takes you back to number 9 and 10. It says A and B are the same, but it uses the intersection. The intersection. The answer to that is B. And I would draw it out. I would draw it out. I would have like a dot for A and a dot for B and see where there was both a blue and a red dot. We just worked 12. There's no way the calculator can do this problem. You have to figure it out, write it out. And it ends up being 200 times 199. Anybody want to see number 12? Answer's A. These, we just talked about them. 13 is a combination, and it's 84. And the last one's 90. Beth, what about homework from this group? Are we good?
They each have received an email from me if they have missing assignments.
Okay.
So they should be able to check that email or check the classroom. Everything's updated and accurate at this time.
Okay. Has everybody signed in a chat? I'm looking at it now. Oh, the boss never knew about Google. I just saw that. You didn't know that that's why they named Google Google? They were math nerds just like me, but now they're rich man nerds, unlike me. Yep, they wanted a Google. They wanted 10 to the 100th power, and they far exceeded that. Beth, is there anything else you need to add?
No, not right now.
John, Daniel, boss?
Nope.
We're all good?
All good.
Up with your work. Beth, when we have that last 2 weeks from today, the last period, when will be the deadline for the final? When do they have to have it back in? Friday night, Saturday morning?
Well, I think that probably comes from Adrian and Daniel and John, whatever.
Would you say Friday at midnight, Adrian? All pre-test or all post-tests?
Yeah.
Okay.
So you'll have a day and a half to do that. I hope everyone still on sees that. But if you stay up with the homework, there won't be any problem. Well, I've gone over 4 minutes like I always do, but that's because math is so much fun. Hey, Beth. Beth.
What?
Potatoes, what day do they not like? Time.
Not sure.
Friday. They hate Friday. The way John's forehead, that must have been a good one. Bye-bye. I'll see you all later. See you